Hey everyone, so you clicked on this video because you're interested in learning a little bit about probability, at least the basics, right? How to find favorable outcomes, how to find all the possible outcomes, and then calculate the probability as a fraction, decimal, or percentage. In addition, maybe you're interested in learning about the complement of an event. Well, in this video, I'm going to show you how to get started with learning probabilities. If this is your first time on my channel, my name is Peter. I make math tutorials covering different math topics from probability to fractions to equations. Most math topics, almost all math topics that are taught in high school. Please consider subscribing to the channel and share this video with friends or somebody who might find this content interesting. If you're ready, grab your calculator and let's get started. So let's start off with understanding the definition of probability and the different types of probability. So the probability of an event, something that you're interested in, is how likely that event will occur. Another way to think about it is what are the chances of that event occurring? So we use probability, it's a numerical measurement to tell us how likely that event is going to happen. And there are two ways that we look at probability. One way is theoretical probability and the other is experimental probability. Theoretical probability is when all the outcomes are equally likely. So this is sort of like using mathematical reasoning to come up with those probabilities. Experimental, on the other hand, is using data to figure out what are the probabilities. So you use some type of data collection method to figure out what are the chances, using experiments, using trials to get what those probabilities are going to be. How do you express probability? There are three common ways to express probability. Number one is using fractions. In this video, I'm only going to use fractions, and this is possibly the most common way of expressing probability. Number two, percentages, and number three, decimals. All of them will yield numbers that have equal value. So if you have a fraction that's a half, in terms of percentage, that's 50%. And as a decimal, it's 0.5. You can express probability in any of these three ways, but I'm going to be using fractions. Another important concept in probability is to understand the scale on which probability can be measured. So probability will always be between 0 and 1 if you're thinking about it in terms of fractions or decimals. If you're thinking about probability in terms of percentages, it would be from 0 to 100%. So in this image here, I have the scale starting from 0, and we describe 0 as impossible. If your event is right in the middle, smack in the middle, 0.5 or 1/2, we say that it's equally likely. And if that probability has a 1 or 100%, we say that it's certain. It is sure to happen. So here's two examples for us to think about what it means to be impossible and what it means to be certain. So if you have a flag, so here's a flag of a country, an African country, Madagascar, and somebody asked you, what's the probability of selecting the color blue in that flag? That probability would be 0. It's impossible. You cannot select the color blue in that flag. Now, on the other hand, if something is certain, I have a picture of Isaac Newton sitting underneath a tree and an apple is falling. And so what's the probability of an apple falling from a tree and landing on the ground? So that probability would be a 1. The apple is not going to fall from the tree and fly into the air. So we know that always when an apple, or even any fruit for that matter, it falls from the tree, it's going to fall to the ground. So that probability is a 1. Always probability will be between 0 and 1 or 0 and 100%. So after looking at the scale, the probability scale, the next thing is how do we calculate theoretical probability? So how do we use mathematical reasoning to figure out the probability of an event? So the notation we use in mathematics is we write P parentheses event, whatever event we're interested in, is equal to, as a fraction in the numerator, we count the number of favorable outcomes, whatever we're interested in, divide by all the number of possible outcomes. And this fraction in the simplest form will tell us what that probability, the probability of that event is, the theoretical probability. So the first example we're going to look at is using the context of planets. So in the first question here, we want to find what is the probability of choosing a planet that is smaller than the Earth in terms of its size. So here we have a chart that shows the smallest planet is Mercury and the largest planet is Jupiter. So there are 8 possible outcomes because there are 8 planets. We don't include the moon. So there are 8 planets, and out of those 8 planets, only 3 planets are smaller than Earth. So the probability is 3/8. This fraction cannot be simplified, so we leave it at like that. In the second picture here, we've organized the planets according from distance from the sun. So now we want to calculate what's the probability that the planet is closer to the sun than Jupiter. So there are only 4 planets, 1, 2, 3, 4 planets that are closer to the sun than Jupiter. So 4 are the possible outcomes out of 8, which is the total possible outcome. So 4/8 can be simplified to 1/2. It's really important that you always simplify your fractions. Let's take a look at a different example here that involves a spinner. This is a very common math problem context, and so let's see how we would figure out the probabilities. So in the first question, we're asked to find the probability of choosing the color red. So in this spinner, there's only one color red, and out of all the colors, we have 9 colors. So the probability will be, we put the number 9 in the denominator because that's the total number of possible outcomes. And then we put the number 1 in the numerator to indicate the color red. So this fraction cannot be simplified, and that would be the final answer. The second question says the probability of the color white. So when you look at this spinner, there's no color white. It's impossible to get the color white. So what value do we assign color white, or something that's impossible? It's the number 0. So probability here will be 0. Now the probability of 7, we see that there are 9 possible outcomes. So the number 9 goes in the denominator, and since there's only one number 7, we put that in the numerator. Probability of less than 2. So you want to choose a number that's less than 2. So there are 9 possible outcomes, and there's only one number that's less than 2. That's the number 1. And then finally, the probability of choosing an even number. So in this spinner, there are 9 outcomes, and out of those 9 outcomes, we want even numbers. So there are only 4 numbers that are even. This fraction cannot be simplified, so that means our final probability is 4/9. The final concept we're going to look at is complement of an event. The complement of an event consists of all outcomes in the sample space that are not in the event. So another way to think about this, the complement is pretty much what you don't want. Those are the events you don't want. So if you want to calculate the probability of the events that you don't want, you can easily subtract 1 minus the probability of the things that you want, the favorable outcomes. The sum of complement, which is probability of not event, plus the probability of the favorable outcomes, probability of event, the sum of those 2 probabilities should always be equal to 1. I'm going to give you some examples to think about why is this concept important. So the third example here, it involves a spinner, and the first question says find the probability of 7. This spinner has 9 total outcomes, but there's only one 7. So that means the probability here is going to be 1/9. Very simple, straightforward. Now if you want to find the complement of probability of 7, it would be probability of not 7. So that means we need to find all the outcomes that are not 7, and the total number of outcomes that are not 7 are 8. And the total number of outcomes in a spinner are 9, and so that fraction would be 8/9. Another way to find that probability is to subtract the probability of 7 from 1. So 1 minus 1 over 9, and that will give you 8 over 9. You get the same answer. Either you subtract from 1 or you count all the outcomes that are not 7. Now what about colors? Let's see, the probability of blue, there's only one blue out of 9 colors, so the probability would be 1 over 9. Now what about the complement of blue? It would be not blue. So you want to count all the colors that are not blue. So you could do that, or an easier way to subtract 1 minus 1 over 9, we're subtracting the probability of finding blue from 1, and that will give us 8 over 9. So there are two ways you can find the probability of a complement. You can either count everything that is not the event, or you can find the probability by subtracting the event from 1. So here's some independent exercises for you to try on your own. On the left side here, you have a spinner, and on the right side, you have a die. So check out the probabilities, and the answers are in the description box below. Alright, I hope you found this video useful. I find it interesting, and I hope it helps you in understanding probability a little bit more. If you found this video interesting, as always, please like the video, share it with somebody who finds this content interesting, and also comment below in the comment section. Let me know which math topics you'd want me to cover. Until next time, bye-bye.